Hello friends, in this video I'd like to solve the following problem from the Spanish Mathematical Olympiad final round 1984, problem number 8. We wish to find the remainder upon division by x squared minus 1 of the determinant, this determinant here. So give this problem a try. My hints are as following. First of all, by calling this determinant p of x, it's clearly visible that p of x is in fact a polynomial, because if you think about it, the formula for determinant involves only multiplying and adding terms of a matrix. So by either multiplying or adding these entries of our matrix, we clearly don't step outside of the ring of polynomials. Moreover, by the well-known division theorem, after division of our polynomial p of x by binomial x squared minus 1, we get some remainder, and this remainder is of degree less than degree of x squared minus 2, i.e. it's of degree 1 or less. And then finally, if we have this equation, we can find the values of a and b by plugging in x equals plus or minus 1. So give it a try and see you in a moment. Okay, so I hope that you managed to solve it. So, as I stated, p of x can be expressed as x squared minus 1 times some quotient plus our remainder. And this remainder is what we want. And now, let's see. If we set 1 and minus 1, we get the following. This part disappears and we have just a plus b, and p of minus 1 equals minus a plus b, and from these two equations it can be derived that a equals p of 1 minus p of minus 1 over 2, and b equals p of 1 plus p of minus 1 over 2. So now we just need to find p of 1 and p of minus 1. So let's plug it in our matrix, in our determinant. So p of 1 is just the determinant of the following matrix: 4, 6, 3, 2, 2, 3, 2, 1, 1, 0, 1, 2, 0, 2, 3, 3. And, well, we should be able to find this determinant. It's 4 by 4 determinant, so there is no accessible explicit formula. So we must do the well-known tricks. So we can, for example, take our first row and make zeros in one column. So for example, I will produce zeros in the second column. So the second row, the third column, sorry. So the second row can stay the same. And now I will take my first row, multiply it by minus 1 and add it to the third row. So I will get minus 4 plus 3 equals minus 1. 2 times minus 1 plus 2 equals 0. Minus 1 plus 1, 0 as well. And here we have 3. And finally, let's take first row, multiply it by minus 2. And we will get minus 8 plus 2 is minus 6. Minus 4 plus 1 is minus 3. Here we have 0. And here we have 3. as you can see, now we have zeros and 1 in our third column, so by well-known formula, this determinant is just -1 to the power, looking at that number 1, it's the index of a row plus the index of a column. So it's the first row and third column times the smaller determinant, which is determinant of 3 by 3 matrix when we cross out the first row and the third column. So 6, 3, 2, -1, 0, 3, -6, -3, 3. Okay, very well. So now -1 to the fourth is just 1. And now we can either use the sub rule, or we can do our trick again by producing zeros in one of our columns or rows. And maybe I will, for example, take the first row and I will try to produce zeros in these places. Okay, so the second column stays the same. And now I take first column, multiply it by 3 and add it to the last column. So 6 times 3 is 18, 18 plus 2 is 20, -1 times 3 is -3, -3 plus 3 is 0, -6 times 3 is -18, -18 plus 3 is -15. Okay, so again, we have zeros and -1 here. So our determinant is this term times -1 to the index of column plus the index of row. So it's second row, first column, times the determinant of 2 by 2 matrix. 3, 20, -3, -15. So it's just this determinant of this matrix, and again we can take first row and add it to the second row. So we will get 3 times 1 minus 3 is 0, 20 minus 15 is 5, and again this determinant is just 15 because it's just product of these numbers minus product of these numbers. Okay, so we have our first determinant, and now we just need to find a very similar determinant by plugging in -1s. So the last 3 columns will stay the same. But now by setting x equals -1, we will get -1 cubed plus 3 times -1 is -4. The second entry will be 1 minus 5. It's -4 as well. Then we will have 3. And finally we will have 0 in the last entry. And again, let's take this number 1 and let's produce zeros in the third column. So the first row stays the same. The second row can stay the same as well because we have 0 already. And now we take first row, multiply it by -1 and add it to the third row. So we have 7, 0, 0, 3. Very well. And now we take first row, multiply it by -2 and add to the last row. So we have -4 times -2 is 8. -2 times -2 is -4. -4 plus 1 is -3. 0, 3. Okay. So we have now minus 1 to the power its first row, third column, times the smaller matrix, the smaller determinant, minus 4, 7, 8, 3, 0, minus 3, 2, 3, 3. Okay. And now we can take, for example, again, first row, we can take first row and produce zeros in the last row. So it's minus 4, 3, 2, 7, 0, 3. And now by adding, we have 4, 0, 5. Again, we have zeros in the second column, so we have 3 times minus 1 to the power 3 stands in the first row, second column, times the smaller determinant. So it's 3 times minus 1 to the third power, so it's minus 3 in fact. And now let's compute this determinant. It's 35 minus 12. So it's minus 3 times, let's see, 35 minus 12 is 23. 23. So we have minus 69. Okay. And now let's go back to our formula for A and B. Our formula for A and B were established here. So A is just 15 minus 69 over 2. And the second number is that. And after doing these operations, we get 42 and minus 27, I believe, which means that our final result, p of x modulo x squared minus 1, I mean polynomial remainder, the remainder after polynomial division, it's 42 times x minus 27. And that is our answer. Okay, so I hope that you learned something new or that you have enjoyed this video, whatever. Thank you for watching and see you next time. Bye.